Greetings and welcome to Make Programming Fun Again. My name is Karol Moros, and in this video I'm going to show you how to set up Tailwind CSS for use in a web application written in Go. I'm going to be using Temple templates. Temple is kind of confusingly named, but it's basically an alternative templating language for Go. And I'm going to be using ChiRouter, which simplifies matching on URLs and HTTP methods. And I'm going to be managing versions of Go and Node.js using Mise. Now, Mise is a polyglot version manager that is very good at managing and installing versions of tools such as the Go toolchain, Node.js, Deno, and a lot more. Now, I already have Mise installed on my machine, so I'm not going to install it on screen. So we can start by creating an empty directory. I'm going to call this directory oikaze, which is the Japanese word for Tailwind. I'm going to change into this directory, and using Mise, I'm going to set versions for Go, Node, and PNPM using Mise use. And the next thing I can do is I can create a Go project using go mod init, and I'm going to call the project github.com/moros/oikaze. In here, Moros is my GitHub username, and oikaze is the name of the project, and this is going to be the URL where you can find this project on GitHub. Now, at this point, in this directory, we have two files. Go.mod is Go toolchains settings file, and it contains metadata about the Go project. And mise.toml is the file created by Mise that tracks versions of the Go toolchain and Node and npnpm. And the next thing I'm going to do is I'm going to initialize a Node project using pnpm init. This created a package.json file, and this file is going to be used by pnpm to track dependencies for the Node project. Because even though the application is written in Go, we're going to be using Node to run the Tailwind toolchain because it's currently a dependency. At this point, I'm going to install Temple. And since I'm running Go 1.24, I can use the new shiny -tool flag. And what this does is it's basically an implementation of a former workaround. It's included in the Go toolchain itself. This used to be kind of problematic because when you develop Go projects, there are a lot of tools that are actually only used as binaries, and you don't really import them in code. And Temple is an example of a tool that is used a lot as a binary. So I'm going to install it using this tool directive, like so. And I'm also going to add ChiRouter as a dependency for this project, like so. If we open go.mod now, you're going to see a lot of indirect dependencies, and we're going to see that Temple has been added as a tool dependency. The next thing I'm going to do is I'm going to install the JavaScript dependencies. I'm going to be using Tailwind CLI, so I'm going to have to install these two Node packages. I'm going to install them using pnpm. So at this point, if we open package.json, we're going to see these two packages have been added as dependencies. And a side effect of running pnpm install is that we now have a node modules directory. And as you know, node modules directories can get very big very quickly. So we need to create a git ignore file to ignore node modules. Okay, and at this point we haven't really created a Git repository, so I'm going to use this moment to initialize a Git repository. I'm going to stage all files in this repository for the commit, and I'm going to create an initial commit. And now we can finally start writing some code. So I'm going to create a file called main.go, and in here I add package main and func main. And normally I would do a hello world, but I think we can actually do a proper HTTP-based hello world. And by that I mean that you can write a handler function that's going to write hello world as HTML, and it's going to be written to a socket. So this is basically going to be a very simple HTTP server, a very simple web application. And since this is going to be a handler function, it's going to take an HTTP response writer and a pointer to an HTTP request. And I'm just going to use fmt fprintf to write to the response, and I'm going to write a simple HTML snippet, like so. And then inside function main, I'm going to initialize a router using chi new router, and then I'm going to serve this page at get slash, which is the main route in an HTTP application. And then I'm going to print an information saying print ln listening on port 3000, and I'm going to call listen and serve, and we're going to be listening at port 3000. So I'm calling HTTP listen and serve with port 3000 and the router. So now if we run this project using go run, we can see that the application says it's listening on port 3000, and if we go to the browser and open localhost 3000, we indeed are getting a hello world message written in HTML. And you can also see that this is exactly the content I have printed to the response writer. So for now, I'm just going to close it, and we can set up templating. And in this directory, I'm going to create a simple Go file. I'm just going to call it helpers.go, and at this point, we are not going to put any code other than package templates inside. And this is because temple files are compiled to Go code. This generated Go code is not going to exist before we actually compile the templates. The LSP can be a little fussy about it. And now I'm going to create another file called layout.temple. And this is going to be the actual template file. And here I'm going to use the temple directive to define a layout. Now these templates kind of behave like functions. They're not exactly what they claim to be, but I'm just going to quickly define a simple layout. So it takes a string, which is going to be the title of the page, and using emmet, I'm going to create a very simple HTML snippet. And here I'm going to interpolate this title as the title of the page. And inside the body, I'm going to use the children directive to interpolate, like to insert the contents of any component wrapped in this layout to inside of the page body. And then I'm going to create another file called pages.temple. And this also belongs to the templates package. And in here, I'm going to write a simple home page. And this is wrapped in a layout. And I'm going to use the title Tailwind plus Go demo. And it's going to be, I'm going to use h1 and say hello from temple, like so. So now I can run temple generate, and it says that it generated two two Go files. And if we open this file, it's a lot of very unfriendly generated code. So I'm not going to commit this to the repository. Instead, I'm going to ignore all files whose names end with _temple.go, like so. And we can see that these files are indeed being ignored by Git, which is indicated by this icon in my editor. So this way we can now try to render this template in the handler, and we can now call templates.index, and then we render it in the context of the request, and I'm going to pass the response writer, and then I can remove the original fprintf statement, and I'm also going to add the content type header. Technically, the standard library would also add it for me, but this way we don't have to run the content type detection code. And the char set is going to be UTF-8, like so. So now, if we run this program and visit this page, we can see that we are getting a lot of HTML, and this is exactly the code that has been rendered from our template. So I think this is a good point to commit. So staging everything for commit, let's see what we are actually going to get committed. We can git commit set up temple. And the next thing we're going to have to do is we're going to set up the Tailwind CLI. And I'm going to set up two commands. One is going to be called watch, and another one is going to be called build. And the watch command is going to be running in development while we are building a website. It's going to need an input file, so I'm going to create a directory called assets src for source, and I'm going to create an entry point. It's going to be called style.css. We can then try to kind of figure out a way to compile this file. I'm going to call the import Tailwind CSS directive in this file. This is everything that is currently required for a Tailwind CSS project. And now in here I can call npm run tailwind CSS. Was it this command? What was the actual command? Okay, it says I have to call npx tailwind CSS CLI. So tailwind CSS CLI, like so. Will it run with npx? Okay, it will. So I'm going to pass the newly created file as the input, and the output is going to be assets dist style.css. So this is a convention that this is the source and this is the distribution, the distributable package. And I'm going to pass watch equals always, like so. So now, if in templates we decide to add a class like text3xl, we're going to see that Tailwind CSS successfully detected this change. And inside this dist file, we can now see that it did indeed generate the class text3xl. And this is a big difference between older versions of Tailwind, which basically forcefully, they did a brute force approach. They generated all possible classes for your Tailwind version, and then they just deleted those that you weren't using. Now, Tailwind 3 and 4 take a completely different approach. They scan your views, and they only generate the classes that you're actually using in the code. So I think this is a great improvement, and I've never really been a great fan of Tailwind, but actually I can tell you that with Tailwind 4 it's actually not so bad. And since this is a generated file, I'm going to ignore it in git ignore. So now we can see that Neolim has hidden this file. So now another thing we're going to have to do is we're going to have to serve those assets. That's something I always keep forgetting how to implement. I think it was something like chi router serve assets, like so. Serve static files. Okay, yeah, this was more or less this command, router handle assets, like here. So we're going to have to create an HTTP file server, and from assets dist. Okay, yeah, HTTP dir. Oh yeah, I think like this, HTTP dir assets dist. And then router handle everything at assets asterisk is going to be HTTP strip prefix fs. Okay, the prefix is assets, like so. Wait, HTTP file server, like so. Okay, this seems to be the correct syntax. I always find it very confusing, but let's see if this actually works. So now if I go run dot, and if in layout temple we also need to add a link, like so. So we have to link the actual CSS file in the HTML. I'm going to have to regenerate the templates. So temple generate and restart the server using go run. So now if we go to this page, we are now getting styles. So if I try to add some more styling, like let's say this is going to be font bold and the margin on top is going to be 2 rem and the margin on the left side is going to be 1 rem. And we're going to have to regenerate templates and restart the application, like so. So now we can see that the styles we have added in using Tailwind have been applied. So this already means that the application is working the way we expected, but this is not very convenient to have to regenerate templates every time you change something in your code. So I'm going to install another tool called mod with a double D, and I'm going to install it the same way I install Temple using go get -tool, and I'm going to paste this URL, and now I run go install tool. So now we're going to have to create a configuration file called mod.conf, and also we haven't finished setting up this yet. I'm going to copy this command. I'm going to paste it in package.json, and I'm going to do something very similar in here, except that instead of watch equals always, I'm going to use minify. I think that was the way it was written. So if I run pnpm run build, was it npx, like so? I think this is the way it was supposed to work. Yep. So now we're going to have two commands, and the watch is going to be used in development mode, and build is going to be used when we actually want to deploy this website. And in the mod configuration file, we can now say that we want to run this node mocho as a daemon, so pnpm run dev, and then another daemon is going to be temple generate watch, like so. And then anytime a Go file has been modified, and if it's not a test underscore test.go file, we want to run a daemon, and it's going to be just go run dot. So now if we run mod in here, oh, it's not pnpm run dev, it's pnpm run watch, like so. So now we can see that the temple is generating templates, that Tailwind CLI is regenerating styles, and that the server is running. And the server is still running correctly if I refresh. So now in this pages temple, I can try to make some modifications. So I'm going to change the color of text to salmon. So we can see what happened is apparently templates have been regenerated, and then Tailwind regenerated these styles, and then the server has been restarted. So now if we refresh the page, it's actually in salmon color, and you can see that the changes are pretty quick. Yep, I think this is a pretty decent setup. If you have enjoyed watching this video, please consider liking this video, and if you really enjoyed this video and want to learn more, you can consider joining the waiting list for my Discord server. And the waiting list is at discord.moros.dev, and I have actually made several videos. I have made 2 videos about this website, one when I set it up and another one when I deployed it. And this website is open source, and you can sign up for the waiting list. And once we reach 100 people signed up for the waiting list, I'm going to set up a Discord server. So thank you for watching. I hope you learned something, and I'm going to see you in the next video, which is going to be another installment of the Write an Interpreter in Go series. Thank you and goodbye.